everyone, welcome back. Oh, it looks like my camera has decided to go on blurry mode, so woo, doing it live, always very interesting. Our next talk is going to be presented by Isaac Na. Isaac is a software engineer at Amazon, a homemade pizza maker, a Super Smash Bros. Melee enthusiast, and he's also involved in the Council Data Project, which is an open source project that uses Python to provide tools for making city council transcripts, legislation, and voting records searchable through a single website. Today, Isaac's talk is going to be called Council Data Project Infrastructure as Code for Civic Transparency and Accessibility. We're going to be learning about the CDP's backend and primarily focusing on the creation of low-cost ETL pipelines and infrastructure as code setups. Isaac, is there anything you'd like to add before we jump into your talk?
Yeah, thanks, Robin. I don't have too much else to add, but I'll just say if anyone after watching this presentation is interested in Council Data Project, feel free to reach us at councildataproject.org or reach out to me personally.
Amazing. And Isaac will also be doing a Q&A afterward, so please do drop your questions in chat or drop them in the Q&A room after we're all done with this talk. So with that, we can go ahead and take it to the recording.
Hey everyone, my name's Isaac Na, and I'll be presenting at PyCascades 2022 today on Council Data Project, focusing on how our project is infrastructure as code for civic transparency and accessibility. Just as a heads up, we won't be delving into any specific aspects of Python itself, but rather showcasing our project that is built in Python and some various tools in the Python ecosystem that we leverage in our project. So what exactly is Council Data Project, or as we like to call it, CDP? CDP is an open source project started in Seattle, but with contributors in multiple locations. And the goal of Council Data Project is to increase transparency and accessibility in the actions of local city councils and other governing bodies. What Council Data Project essentially is a website that hosts videos, transcripts, and voting records in a single website for governing bodies of any size. And this governing body can be something like a city or even a larger group such as a county. So let's run through an example of how CDP works. So here we're at CDP's landing page, which just kind of gives a summary of what we're about. And let's go to the King County deployment. So let's say I want to search a topic such as COVID and how it's used in our local King County Council. That's our search page, and now we're entering our event search results page. So here it'll link me all the meetings in the King County City Council for the various search terms that we can provide. And here we provided COVID. And so let's click on, we can actually search by committee. We can add some filtering. We can also filter by dates, and we can even filter by things such as relevancy and age. So let's click on one of these results, and here we can find the video of that meeting. We can find the full agenda of that meeting, and then we can see the transcript as well, which we generate ourselves using Google Speech to Text. And we can see votes for any legislation or bills that are brought up during the meeting. And so a really cool feature that we have in CDP is the ability to jump to certain timestamps. So let's say I want to see exactly where this sentence involving COVID is spoken. And yeah, so we allow automatic timestamp jumping, which is very useful for parsing through large amounts of data and trying to look through your search results. So for a TLDR of CDP's features, for a single deployment or a governing body that the website will be for, CDP provides plain text search for a governing body's meetings or events and its minutes items. CDP will provide the ability to filter and sort those events based on various criteria. CDP also provides automatic timestamped transcript generation that we can either generate through closed caption files or through speech to text using machine learning. We also provide the option to share an event at certain timestamps. If you want to, let's say, share a certain council member talking halfway through the meeting, you can easily share those. We also provide full events minutes details with all the related documents. And we also have several features in development that we're working on adding, such as speaker recognition, legislation tracking, and notifications when certain topics occur. Before we jump into the more technical details of the presentation, I just wanted to share a little bit about myself. My name is Isaac. I'm a software engineer at Amazon, and I'm living in Seattle, Washington. I majored in computer science at Washington University in St. Louis, and I graduated in 2019, and I've been living in Seattle ever since. I've been an open source developer with Council Data Project since late 2019, after I discovered them through a hackathon that's sponsored by a local Seattle Tech for Good organization called Democracy Lab. And for CDP, I mainly work on backend features, but I'm trying to dabble in a little bit of everything just to learn as much as I can. And in my free time, I climb, I play Super Smash Bros. Melee competitively, and I picked up pizza making during the pandemic. Circling back to Council Data Project, some key aspects about the project is that it's open source, because we believe that CDP should be collaborative and open to the public, and we welcome anyone that wants to contribute. Another aspect is that it's civic tech, because CDP aims to improve the community relationships with the government using technology. Council Data Project is infrastructure as code, because we provide a scalable, reproducible infrastructure so that anyone can easily spin up a CDP deployment for their local community. And it's archival, because CDP stores and organizes data for future accessibility and historical purposes. With designing a civic tech project, there are some core ideas that we try to follow in Council Data Project. The first is transparency, because technology used by the public that shares public information should be accurate and unambiguous for both practical and ethical reasons. It should be easily deployed, because for a project to gain adoption, it should be easy to start a new deployment, especially considering that each deployment could have independent maintainers. It should have a low technical barrier, because of a project that's dependent on volunteers that could have a wide range of technical backgrounds should be easy to launch and maintain. And the cost should be low and decentralized, because projects that are purely for public use may lack large amounts of funding, so we want to keep CDP as low cost as we can, with billing handled independently by each deployment's maintainers. It seems a little bit late to just start talking about Python during our presentation, but we wanted to go over a few reasons why we use Python in Council Data Project and some of the advantages that it provides. The first advantage is that it's prototype friendly. CDP has a relatively small team, which leads to each individual contributor having a large impact with a lot of room for experimentation. And because Python has simple syntax and is an interpreted language, it allows for rapid prototype development to support this type of work. Python also has a low barrier to entry. The simplicity of Python makes it a really easy language to pick up, and this is good for either newcomers or developers that usually work in a different type of language. Volunteers for open source projects can have a wide range of experiences and backgrounds, so a low barrier to entry is a pretty important factor. Python's ecosystem also has a plethora of open source libraries that we can choose from. We have collaborated with maintainers from several different libraries and even contributed to some of them to support our specific use cases. Another reason that we chose Python is just because it's our favorite language. Python is my personal language of choice for any side project or small scripts that I've worked on, and I really enjoy working with it in Council Data Project. There are two major points that we want you to take away from this showcase of Council Data Project. The first is that you can squeeze a lot of value from existing services and platforms. This helps you build a project cheaply and effectively which are important aspects for civic tech. We'll showcase several of these services that we use in CDP later in the presentation. The second is how useful Cookie Cutter is for project templating, and how combining it with infrastructure as code is a really easy way for scaling deployments. Later in this presentation, we'll expand upon and demo Cookie Cutter and also go over Plumi, an infrastructure as code platform that we utilize. Now, let's transition over to talking about CDP's deployment system and begin the conversation of how CDP is an infrastructure of code project. So moving on, this diagram represents CDP's deployment system. At the top left, you have CDP Backend, which stores all the business logic and data processing pipelines and reusable tools, along with transcription logic. And in the top right, we have CDP Design, which contains the assets and logos that we reuse in CDP, and CDP Frontend, which contains the reusable React components that are used in the front end. And in the center is Cookie Cutter CDP deployment, which kind of ties everything together. It is essentially a reusable template that's used to start up a new deployment, and it creates a GitHub repository to host and manage all the database infrastructure, runs and schedules all the pipelines, and will host your deployment's website. And some examples on the bottom are Portland, Seattle, and King counties, which are examples of deployments that are spawned from the Cookie Cutter template. In the last slide, we mentioned Cookie Cutter. And Cookie Cutter is essentially a command line tool that's used for creating projects from templates, and it can be used for any programming language. So it's not specifically for Python, but can be used for anything like JavaScript, which we actually do in Council Data Project. I wanted to give a quick demo of Cookie Cutter because it's a very interesting technology that we use in CDP, and a demo will really give a better understanding of it. So here we have a cloned version of Cookie Cutter CDP deployment. So I just want to show you how this repository is set up. We have in here the template that will be used to generate the child template, if that makes sense. So let's go into that. We see that there is a YAML file that contains all these variables that will be reused throughout the whole repository. So anytime this tag here is used in that repository, whatever the user provides for example, municipality, will replace wherever this line is. So for example, if we go into the event gather config, we'll see that this get events function path has the Cookie Cutter tag in it. So whatever the user provides for the Python municipality slug will replace this. So let's actually work through that. Here I've already installed Cookie Cutter via pip. And if we run now Cookie Cutter and provide the link to the Council Data Project repository, it'll start prompting us through the workflow. So let's give this some time. So yeah, now it's asking us what we want to provide for each of the fields that we mentioned earlier. So let's just do some examples. Here we can define the governing body type. Let's just say a city council. We can just provide the same thing here. Test123 is the default value that it takes from the municipality, and we can provide a separate custom value if we want. Same thing there. Same thing there. We can say this is our PyCascades demo org. We'll say PyCascades. Same thing. We can just provide the default values here, and this allows us to pick our Firestore region, which is important for minimizing cost across potentially cross-region calls. So let's just choose US West 2 since we're on the Pacific Northwest. And yeah, we've generated our repository. So we can cd into this. If we look in our YAML file, we can see that all these values have been replaced with what we provided. And if we go back to that same file, that event gather config, we'll see that that tag was replaced with the value we provided for the Python municipality slug. And that's just kind of an example of how Cookie Cutter works. So Cookie Cutter is a useful library to help set up an infrastructure as code project, but why did we design CDP to be infrastructure as code? To start off, CDP has decentralized management across deployments, and infrastructure as code lets us provide consistent and reproducible environments. This is useful for reducing one-off errors and debugging issues. Minimizing obscure configuration and keeping environments reproducible allows easier adoption for future deployments, which is important in an open source project such as ours. Now let's go over a diagram that kind of encapsulates all of CDP's core infrastructure. So this is more of a representation from a logical/functional view. The main idea is that there are core components, with the top left being the event gather pipeline, which essentially gathers and cleans all our data for meetings and events and generates the transcripts and thumbnails and stores the data. And in the bottom left, we have the event index pipeline, which indexes the transcript data so that it's more search friendly, and this improves user search capability beyond just a raw string match. And in the top right, we have the web application building, which essentially just builds the web application routinely for any updates. And all these components can be tied together with scheduled cron jobs or be triggered manually. And this is all kind of tied together through Firebase and Google Cloud Storage, which we use to store our data. And the deployment website is what the user sees and interacts with. Now let's go over some platforms that we leverage in CDP's core infrastructure. So we've mentioned it a lot so far in our presentation, but we leverage Google Cloud Platform heavily in CDP. We use Firebase as our non-relational database, and we use Google Cloud Storage to store transcripts and other related files. We use Google's speech-to-text to generate transcripts for meeting videos, but CDP is versatile, so we're not exactly tied to Google Cloud Platform, and we're tentatively considering moving to a different relational database in the future. Another platform we use for infrastructure management is Plumi. Plumi is an open source platform for infrastructure as code that has support for many existing cloud platforms like GCP or AWS. It lets you easily define configuration with code as opposed to having very large like YAML files or something like that. And with the way CDP uses Plumi, deployments can be eligible for free tier pricing. And Plumi is also developed here in Seattle, so we love supporting our local Seattle startups. Another cool tool that we use is Prefect. Prefect is essentially a workflow management framework. In Prefect, we define tasks and organize them in such a way that we can compute a DAG and let Prefect handle all the asynchronous processing for more efficient pipeline runs. And in CDP, we use it for our ETL pipelines. Another tool we use for automated workflows is GitHub Actions. GitHub Actions are a simple way to schedule and automate workflows through YAML files. For CDP, we use them specifically for our data processing pipelines, such as event gathering and indexing. We also use GitHub Actions to run checks on our PRs for successful builds, unit tests, linting, and code coverage. Actions can also run in isolated and controlled environments for reproducible results, and this makes debugging easier for child deployments as well. And the GitHub Action UI is clean and has built-in logging. And another key aspect is that GitHub Actions are free for public repos, which is, as we've mentioned earlier, very important for an open source civic tech project. Here's an example of the King County actions. Here on the left side, we have our various workflows. We've got the various builds, such as the infrastructure build and the web app build, and we've also got our data pipelines, such as the event gathering and event indexing workflows. GitHub Actions are also really convenient because all the workflows are stored and sorted chronologically, and we can see which actions succeed, such as this one, versus failing with the red icon. And we can also filter by various criteria, such as the branch, the actor, as in who initiated the workflow, and so on. And if we tunnel into one of these specific workflows, we can click in and we can see all the steps for that specific action. So each action is defined by various steps, and each step is logged separately. And so this logging is built in and makes debugging really convenient. And hypothetically, let's say a child deployment was running into issues and they wanted to reach out to the CDP team asking for some help, and they can just link us that run for that specific action, and we can see the logs and help them easily debug. So GitHub Actions are a tool that we really leverage for all of our workflows. GitHub also provides another feature called GitHub Pages for web hosting. For the web portion of CDP, we use GitHub Pages to host the web pages for individual deployments, and GitHub Pages hosting is free, and no domain purchase is necessary, but can be added if desired. For general updates to CDP's core backend package, we release version bumps through PyPy, which can be picked up by deployments manually or through Dependabot, which we'll go over in the future. In CDP, we use the bump to version tool for clean and consistent version bumps. And next, we'll give an example of how that works through a demo. Hey everyone, I just wanted to give a quick demo on bump to version and how we use it to handle versioning and releases on PyPy for our project. So let's say I have some change here that I've added on a commit, and I want to add this as part of a version bump. So let's just make this a minor version bump. So we'll run this command. And if we look at the log again, it actually added this commit here. So with this commit, it already handles all the code changes that are required for a version bump. So it changes setup.py and the other configs. And it also creates a new tag for us, this minor version bump tag for 3.1.0. So I would normally run git push and then git push -- tags to publish the tags as well. So once we run git push, what will happen is that this GitHub action that we've already defined here will check that the commit message contains bump version, and then if that happens, then this whole workflow will be triggered and published to PyPy. So as an example, we can look at one of these past builds for a version bump. We see that this was a 3.0 release. So if I look at this, we can see the published job, and then we see this whole workflow execute. We can look at PyPy and see that the version was published successfully. And then we can also see that the tags that were created as part of bump to version were also published once we ran git push tags. A challenge for projects like CDP that has several individually managed deployments is propagating updates and fixes smoothly, and that's where Dependabot comes in handy. We use Dependabot in CDP for automated updates, and with a small YAML file for any deployment, we can define dependencies that we want each deployment to check for, how often, and from what package ecosystem, such as pip. Dependabot will then create a PR to the deployment's repo for the updates, and this keeps deployments aware of updates without suddenly forcing breaking changes on them, and they can choose whether to accept them or not. This screenshot is an example of a PR that Dependabot automatically generated. Here we have a new release of CDP Backend with the version bump included in the description. We have release notes about what this is about. For example, this one includes a hashing fix. It also includes all the commits that are included in the release, and so individual deployments can check whether they want to accept these changes or not, just in case there's some type of unintended feature that they didn't want to take, or potentially bugs that could be introduced. And that wraps up the presentation. If you want to learn more about Council Data Project, please visit councildataproject.org for more information. You can reach out also through Democracy Lab, which is a local Seattle organization that kind of sponsors civic tech projects and links volunteers up with them and other socially responsible tech companies. Or you can find us on GitHub at github.com/councildataproject. And if you want to check out an example, you can check out our deployment for King County, Washington at councildataproject.org/King County if you want to experiment with Council Data Project and see what our product is all about. And thanks for listening. I hope you enjoyed hearing about Council Data Project and how we maximize existing services to get the most value from them for building this civic tech project, and also how we utilize Cookie Cutter alongside infrastructure as code to build scalable deployments. And I'd like to thank the PyCascades staff for organizing a great event and giving me the opportunity to speak. And thank you to all the other volunteers that work with me on Council Data Project.
Thanks so much, Isaac. It sounds like the Council Data Project is doing really important work, and it was incredibly cool to get some background into what exactly you're doing behind the scenes there, and how someone else might start a project that's similar to this. So thanks so much.
Yeah, thank you, Robin. And yeah, I believe we'll have a Q&A section after this. So yeah,
Yep.
there's some questions I didn't get to answer, so we'll address them there.
Yeah, that's great. Everyone pop over to Q&A if you're interested in hearing more from Isaac. We'll take a quick 15-minute break, and then we will come back for our next speaker. Thanks, everyone.